All right, sailors, happy Friday. All right, we made it. Grinded this week out, got a lot done, had two quick checks, right? The one including today in the grade book, right? We had to get over some obstacles with the Schoology and show our patience there. But it's Friday, right? We made it. I'm looking forward to tonight. Right after school, got eighth grade football practice for a little bit. Then I'm going to go to the varsity, be down on the sidelines helping out and cheering our varsity football team onto a victory over Reese Puffer. Saturday. Hopefully, catch a few college football games, maybe get some yard work done. Do my best to make somebody's day a little bit better. Hopefully, you all have great plans and great things lined up for the weekend, and you could make somebody's day as well. But before we celebrate the weekend, let's get into section 1.5, where we'll talk about variables and equations. All right. Our learning objectives, we're going to identify and solve open sentences. And we're going to translate verbal sentences into equations, right? Which comes in very handy, especially when solving word problems. Our key terms for this lesson is equation. It's a mathematical sentence that contains an equal sign, right? Meaning we can solve it. We can find the specific value for a given variable. And the next one is solving the equation, right? It's a process of finding the solution that makes an equation true, right? We'll focus more on the steps and why they work later on. Right now, we're just going to kind of use some logic and try to figure out what the equation is equal to, or what the variable is equal to on a given equation. All right, so let's look at some example problems here that involve solving the equation. All right, and like I said, we're not going to focus on the steps that you go through in this rote memorization of I got to do this step first and this step. I want us to kind of understand what the equation is saying and see if we can just logically come up with the value. So in number one, we're finding the value of m that would make this equation true, right? And one way to look at it is 12 minus m equals 8. I could just guess at a value, meaning I could say, all right, let's pretend that, hold on a second, little technical difficulty. Got to flip my notepad around. I was going backwards there. All right. So we can say, let's say that m is equal to 2, right? If I did 12 minus 2, does that equal 8? Right? And we should know that 12 minus 2 is 10. So no, that is not my value, right? And I should know that, right, 8 is 4 away from 12. So if I said 12 minus 4, that would give me 8. So my value for m in this equation, or the value of m that makes it equal, is 4. All right, looking at number 2. All right, I want you to pause the video real quick, and I want you to see if you can figure out what the value of x should be, whether you're just plugging in values to see or whether you are actually coming up with another way to solve that. So take a minute and pause the video here and try number 2. And while you're at it, why don't you try number 3? All right, let's see how you did here. And again, you might have just said, all right, I'm going to try x is equal to 5, right? 2 times 5 is 10 plus 1 is like, that's too big, so I'm going to drop it down. All right. Another way to look at it is I have two parts here, right? I have 2 times some number plus 1 is equal to 7. So one way to think about it is I could rewrite that as 6 plus 1 is equal to 7, right? So the 1's match up. Now the other part, the 2x, has to equal 6. So I think to myself, 2 times what is equal to 6? And I should know that 2 times 3 equals 6. So x should equal 3, right? And if I plug that in, right? We practice this evaluating where we plug in values and see. 2 times 3 is 6 plus 1 is equal to 7. So my answer checks out. All right, got that erased again because I do want to show you where this is going to evolve into when we solve equations, because not all of them are going to be nice and clean and where we get an integer value for our solution, right? It's going to get messy at times where we end up with fractions and decimals and whatnot. And we're going to learn something called inverse operations, right? Inverse meaning to cancel out. If an equal sign is our balance, meaning they're equal, I can do the same thing on both sides and it would stay equal. And I would use the reverse of our order of operations and do the inverse. For example, the inverse of adding 1 would be subtracting 1. So here I would have 2x. 1 minus 1 is 0, so that cancels out. And as long as I do it on the other side, it should stay equal, right? 7 minus 1 is 6. So now I have 2 times x equals 6. Well, the inverse of division is, back up, stuttering here. The inverse of multiplication is division. So if I divide both sides by 2, it should stay equal, and I get x equals 3. Right, and then example 3, I'm looking for 5 times what equals 30. And I should know that 5 times 6 is equal to 30. Plug that in and check, and it checks out. Now, 5 times x is 30, right? If we use our inverse operation of division, right? 30 divided by 5 equals 6. So in either way, it doesn't matter how you go about it. All the ones that we're going to look at in lesson 1.5, you should be able to kind of look at it, talk your way through it. But if not, you can always use the inverse operations, which we will be using as we go through pre-algebra. All right, next up is translating the sentence into an equation. It says the difference, right? Difference, that's a key word. We looked at that in the last couple lessons, and I should know that difference means subtract, right? Of a number. So when I have of a number, that's what I don't know. Okay, I don't know. I'm going to call that a variable, right? Let's just use n. You could use whatever letter you'd like. So a number in 10 is, okay, this is a key word in a verbal, and that's equal, right? And that's equal to 17. So the difference between a number and 10, so when I subtract this number in 10, I get 17, okay? So I have to figure out what number I can subtract 10 from and get 17, right? I should know that n, oh, that's bad. Let's try that over here, sorry. N should equal 27 because 27 minus 10 is 17. If we use our inverse, right, what's the inverse of subtraction? Would be addition. And I can see that n would equal 17 plus 10, which is 27. I want you to pause here, and I would like you to try and see if you can come up with the equation for the product of a number and 5 is 40. All right, and then the second part of that would be to find that number, right? Or basically solve the equation that you make. So take a minute, pause the video here, and attempt this problem. All right, hopefully you tried it out, right? And product, right? We know that that refers to multiplication. This number, let's call it B. I don't know why B, it just stuck out. Let's just use B, just so we get used to using different variables so we know that it does not matter what we call that number. And 5, Okay, so and 5 is, right, it's our equal sign, 40. So the product, okay, of b times 5 is equal to 40. Now, you'll also see this written as 5b equals 40 because this implies multiplication. Sorry, that was bad. All right, so what times 5 is 40? Our basic skills, right, when we reviewed those, we should know that 8 times 5 is 40, right? Using inverse operations, we could check by dividing both sides by 5. 40 divided by 5 is 8. So that is our solution to the verbal sentence. All right, time to do some practice, okay? I'd like you to do the following problems from section 1.5. It starts on page 30. Not a super long assignment today. You should work on that. There is also going to be a BuzzMath assignment for you to work on as well. So you can go into BuzzMath and just remember the quick checks, the BuzzMath, anything that's going to be some sort of grade, those are all going to be due by our chapter test, which we'll get a more set in stone schedule next week once we figure out where we're at with everything after we do a practice test. But we're shooting for next Friday as our first test for chapter 1. All right, make sure you try these problems and then you can use the key to check them out. Have a great day. We'll talk to you soon.